Welcome to the General Chemistry 2 class. This section is on electrochemistry. This lesson is about batteries. Let's begin. In this lesson, we will describe the electrochemistry involved in some common batteries such as Leclanché dry cell, boron batteries, fuel cells, and lead storage battery. A battery is a galvanic cell that is used to provide electric energy. Dry cell is a galvanic cell consisting of non-fluid materials inside it. This is also known as the Leclanché cell. After its inventor George Leclanché, it is used to power devices like clocks, flashlights, radio, and other electronic devices. Typical dry cell consists of zinc and graphite electrodes. The zinc consistor itself serves as anode, with the graphite rod located at the center is the cathode. The graphite is coated with manganese 4 oxide in a way that the latter is also contact with the canister. Manganese 4 oxide is coated with a sticky mixture consisting of zinc chloride, ammonium chloride, starch, and water. A layer of paper covers the space to prevent direct contact with the canister. At the anode, zinc is oxidized to zinc ion. At the cathode, manganese oxide is reduced to manganese 3 oxide in the presence of ammonium ion. The overall reaction of the occurs while discharging a dry cell is given as follows. The potential of this cell during discharge, or when in use, is around 1.5 volts. The mercury battery, also known as boron battery, is another type of battery used in watches and certain devices like pacemaker, a device used to control abnormal heartbeats, and calculator. Boron battery consists of steel canister as the cathode and amalgamated zinc as the anode. The canister is filled with potassium hydroxide and a paste of zinc oxide and mercury 2 oxide in water. During discharging, the following cell reaction occurs in a boron battery. At the anode, the zinc in the amalgam is oxidized in the presence of hydroxide ion to zinc oxide, while at the cathode, mercury 2 oxide is reduced to produce elemental mercury. This kind of battery provides a slower voltage, 1.35 volts, than Leclanché cell, but serves its purpose for a longer time. Fuel cell is kind of battery in which the reactants are continuously added while it works as galvanic cell. It is known power source of spacecraft, although nowadays it is also used to electric vehicles. Fuel cell utilize a special porous electrode made from carbon with nickel which facilitate breaking down of the reactants and electron transfer. The overall reaction involved in a fuel cell is same as the combustion, but the steps involved occur differently. Aside from hydrogen, methanol can also be used as a fuel. In some fuel cells, the electrolyte use an aqueous solution of potassium hydroxide. During discharging a fuel cell, hydrogen fuel is oxidized to water in basic medium at the anode. If methanol as the fuel, it is oxidized to carbon dioxide at the cathode. Oxygen is reduced to hydroxide ion. Lead storage battery is an example of wet cell or battery whose electrolytes are in a liquid solution. It is commonly used in automobiles, hence also called the car battery. A lead storage battery consists of two different electrodes, with lead as anode and lead 4 oxide as the cathode. The electrolyte solution to which the electrodes are submerged is aqueous sulfuric acid. During discharging, the half-cell reaction and overall cell reaction are as follows. At the anode, lead is oxidized to lead 2 sulfate. At the cathode, lead 4 oxide is reduced to lead 2 sulfate in acidic medium. Each cell has potential of 2 volts, thus for typical car battery that provides 12 volts of electricity, 6 cells are needed. The electrodes used up during discharging can be replenished through recharging of the cell. However, after repeated discharging and recharging, some lead 2 sulfate particles deposit at the bottom of the cell. This results in lowering of sulfuric acid concentration and consequent lowering of the potential. Nickel-cadmium or NiCad battery is a rechargeable cell consisting of cadmium anode and nickel 4 oxide cathode in the presence of cadmium hydroxide and nickel hydroxide, together with aqueous potassium hydroxide as the electrolyte. It is used in portable devices like cameras. At the anode, cadmium is oxidized to cadmium hydroxide. At the cathode, nickel 4 oxide is reduced to nickel 2 hydroxide. During discharge, this battery has slightly lower voltage, 1.4 volts, compared to Leclanché cell. Lithium-ion battery makes use of lithium metal as the anode and a complex compound oxido, cobalt COO2. Lithium is reactive with water, so the electrode is dissolved in organic solvent. At the anode, lithium is oxidized to lithium ion. At the cathode, the cobalt complex is reduced to lithium cobalt oxide. Cobalt exchange in oxidation number from +4 to +3. The overall cell reaction is given by lithium plus oxido OXO cobalt producing lithium cobalt oxide. This cell has potential of 3.4 volt as a result of high capability of lithium to act as reducing agents. Moreover, it can be recharged for a number of times, thus beneficial as a power source for mobile phones. To summarize, batteries are most useful example of galvanic cell. Like any galvanic cell, each kind of batteries consists of electrodes and electrolytes, which are crucial in engineering electrical energy. Thank you. Welcome to the General Chemistry 2 class. This quiz is about batteries. Let's begin. Number 1. Number 2. Number 3. Number 4. Number 5. Number 6. Number 7. Number 8. Number 9. And lastly, number 10.